The next thing we're going to do is we're going to continue working through surds, but we're going to start rationalizing the denominator. So when we rationalize the denominator, first of all, what does that mean? Well, you know what a denominator is. A denominator is the bottom of a fraction. So that's okay. But do you know how to rationalize? Well, what does it mean? To rationalize means to make something rational. So then you have to understand, well, what is a rational number? So a rational number is one that can be expressed as a ratio of two numbers. So a ratio of two numbers. Whenever we talk about a ratio of two numbers, really we're talking about a fraction. So rational numbers can be written as fractions. Just in black here, any number that can be written as a fraction is rational, but irrational numbers are numbers that cannot be expressed as a fraction. They cannot be expressed as a ratio of two other numbers. So let's just see if we can figure out what that means. On the left hand side here, I have a list of different types of rational numbers. Whole numbers are rational, obviously, because they can be expressed as a fraction. So 7 is a whole number. You can write it as 7/1. Fractions, pretty self-explanatory, they're rational. Terminating decimals that stop, they can be expressed as fractions. So too can recurring decimals. So 0.3 recurring, even though the digits go on and on, you can still write it as a fraction, a ratio of two numbers, 1 divided by 3. So they're all rational. But irrational numbers cannot be expressed as a ratio of two numbers. Pi, we know what pi is, we know what the value of pi is, we know how to use it whenever we're talking about circles. But pi is a special number, it's an irrational number because its digits keep going and going forever. Those digits have no pattern. And because they have no pattern, it means you cannot write pi as a ratio of two numbers. You cannot write pi as an exact fraction. You can have approximations of pi, 22/7 and whatnot, but pi cannot be expressed as a ratio of two numbers, hence we give it a symbol. Similarly, the letter E represents the number 2.7182840 and so on. It keeps going on and on and on. E is another number that you'll use more in A level, but it cannot be expressed as a ratio of two numbers. You cannot write E as a fraction, so we assign the letter E. But we're more concerned really about surds. Root 2, root 3, root 5. Surds that cannot be simplified, so square roots that cannot be simplified, i.e. surds, they cannot be expressed as fractions. So the square root of 2, you type it in the calculator and hit your SD button, it'll not give you a fraction. It'll give you a decimal that keeps going, and obviously the calculator will stop after a certain amount of digits, but those digits keep going and going and will never repeat. Therefore you cannot write it as a fraction. Root 3 cannot be written as a fraction, root 5 cannot be written as a fraction, and any square root that cannot be simplified, you can't take a square number out, they cannot be written as a fraction. Now the key thing is that these square roots, these irrational numbers, should not appear on the bottom of a fraction. So you want to get them up to the top. If you see a square root on the bottom of a fraction, you need to rewrite it. So the types of question you get, so just looking at these questions here from the textbook, look at the denominator. So you have square root 3, 5, 10 and so on the bottom. Now square roots should not be on the bottom. Surds should not be on the bottom. Irrational numbers, that is, should not be on the bottom. So we need a method to write 1/root 3 a different way. So we want an equivalent fraction. A fraction that means the same thing, but it doesn't have the square root of 3 on the bottom. So you need to start thinking about equivalent fractions and how do you make a fraction that's equivalent to another. Remember that whenever you take a fraction and multiply top and bottom by the same value, you will get an equivalent fraction. So 2/3, if you multiply 2/3 top and bottom by the same value, let's just say 5, you get 10/15. So because you've multiplied top and bottom by 5, you'll get an equivalent fraction. So those two fractions have the same value. And we're going to do something similar for these questions. So looking at part A, we need to rewrite 1/3 as a different fraction, as an equivalent fraction. So we're going to multiply top and bottom by the same value, and that value is the square root of 3. because whenever we multiply across the top, remember multiplying fractions, you just multiply across the top and across the bottom. 1 times root 3 is root 3. Now what happens when we take root 3 and multiply it by root 3? We get 3. So the fraction in the question, 1 over root 3, we have an equivalent fraction now, root 3 over 3, but this one doesn't have a surd on the bottom. So that's us done. Part B, we're going to multiply top and bottom by root 5, because there's a root 5 here, and we multiply it by root 5, we're going to get 5 on the bottom. But multiply across the top, you get 3 root 5. So another equivalent fraction, but this time no surd on the bottom. So have a think, what am I going to multiply top and bottom by in part C? Across the top, 7 root 10, across the bottom, 10. Part D, top and bottom, 10 root 5 over 5. Now this one is 1, so previous ones could not be simplified. This one can be simplified. 10 on the top, 5 on the bottom, 2 root 5. So let's do the next 4. Next 4 are slightly different because we have these numbers 2, 3, 3 and 5. So let's just focus on question E. We're going to do the same idea, multiply top and bottom by the same term. Now, if you wanted to, you could multiply by 2 root 3, but there's no need. Just take the surd that's there, that's all. Just take the root 3, multiply top and bottom by root 3. So on the top you'll have 5 root 3. On the bottom, you don't have to do this, all this working out. I'm just showing you that root 3 multiplied by root 3. Just have a think what's going to be in the bottom here. On the bottom we're going to have 2 multiplied by 3, which is 6. Here we're going to multiply top and bottom by, you could do 3 root 2, but there's no need. Just take your square root 2. And on the top you have root 2, on the bottom 3 root 2 root 2. So what's going to be in the bottom then? 3 multiplied by 2 is 6. So G, multiply top and bottom by the same value, and that value is the square root of 2 because it's here. So on the top we have root 3 times root 2 divided by 3 root 2 root 2. So on the bottom we have 3 2's or 6. Now on the top, root 3 root 2, combine that. Remember the rules of surds. If you're multiplying 2 surds together, you can write their product underneath the 1 square root. And the last one, root 7 over root 7, 7 root 5, root 7 over 5 root 7, root 7. So then on the bottom we have 5 multiplied by 7, so that is 35. And on the top we have 7, root 5 root 7, combine them, root 35. And you can simplify the 7 and the 35, divide them both by 7. You have root 35 over 5. So these types of questions, they're non-calculator questions, but if you're doing questions like these at home, you can just type them into the calculator and they will be simplified for you. So I've put up a worksheet for you to try. You can try these now or tonight. So you're just multiplying top and bottom by the same term and then simplify. So have a go at those tonight. It's a separate PDF, so you don't have to look at the video and do them, but you can do them in your book or wherever you want. I'm not getting you to upload them, I'll just go over them tomorrow. Now there's a second set of questions underneath that. Now you can try them if you want. I'll give you a clue about how to do this one, but I'm going to do it in more depth in the next lesson. So treat the bottom, the denominator as its own term, as a full bracket, and what I'm going to get you to do is, like I said, we'll do this more in the next lesson, but we're going to multiply top and bottom by another bracket, Now it's not going to be the same bracket, but it's going to be something similar. So if you think you know how to do those, you can try them, but like I said, I'll do them in the next lesson. The priority is just to get these few questions done, and we'll take it from there.